Hello everyone. This is Kumar here. I'm again back with another Wednesday Talks. This time it is on the microservices. This is the continuation video for the mainframe modernization that I've uploaded last week. So, in the next couple of minutes, I would be going to cover what is microservices by introducing microservices, and we'll discuss about the traditional architecture. The monolithic architecture versus can say like decentralized architecture, that is microservices, and also I'll try to cover some key concepts of the microservices, and also we'll see about the building microservices, how we can build that, and the challenges that we may encounter while building this microservices, and we'll also talk about some real world examples of microservices that is being used today. Okay, so without wasting any time, let's get started. So, talking about the microservices, uh, I know you might be hearing a lot about these microservices, right? So you might be hearing about the API services, web services, and what is this microservices? If you're completely new and if you're not aware of what is microservices, and you want to learn about this, yes, you are in the right spot now. So I'll try to explain in a very simple way. Okay. Yeah, microservices are nothing but it's an approach in a software development where uh, applications are broken down into a smaller independent service. I can say that can be easily communicate to each other. They use a light protocol. It can be REST or it can be a messaging. As I can say, like each microservices perform a specific function. Such it can be like handling user authentication, accounting information, uh, processing transactions, or generating some reports. All these can be brought into a individual services, or we call it as a microservices. And these each microservices can be developed, tested, and deployed independently. What is the advantage of this? This allows for a faster development cycles, and I can also say like you can have more frequent updates. Since we are breaking down the application into a smaller and modular services, microservices enables, I can say like faster development cycle, better scalability, and the greater resilience, right? So most of the microservices are uh, plays a very key role. I mean, since we are breaking down into a smaller services right here. So as I can say, like firstly, I can say like as I'm saying here, like faster development cycle. So how it is possible, right? So they allow for faster development cycle as individual microservices can be developed and deployed independently without affecting the rest of the application, right? So if you look at the traditional approach, so we need to deploy the complete applications, whereas in the microservices, so it can be developed and deployed independently without affecting the rest of the application. And the second thing is microservices enables a better scalability. As individual services can be scaled up and down or down based on the demand, right? Without affecting other services. Since we have already have the individual service developed, so uh, we can either scale these things up or down, so based on the demand that we get, right? And it will not have any impact to the other services. And this provides a greater resilience as if there is any failure in one service, right? That would definitely not have an effect to the rest of the application. So those particular piece of services can be immediately fixed, and the the system is still running, right? So that will not have an impact. Like finally, I can say like the microservices allows for greater flexibility, agility, as well as the service can be easily added. So you can easily add or remove or replace needed without interrupting the rest of the application. Overall, I can say like the microservices are very important approach to software development that can help organization to build more scalable, resilient, and agile applications. So yeah. This covers the introduction. So let's talk more in detail about monolithic architecture and the microservices. I mean, versus microservices, right? So when, as I've explained in the last video about the monolithic approach or the architecture, this is nothing but it's a traditional approach, right? So traditional approach to software development, where the application is built as single, I can say, like unified system. In a monolithic architecture, all the different components of the applications are tightly integrated, couple, and changes to one component can have an effect throughout the entire system. So that is about the monolithic architecture, right? So now let's talk about the microservices. It's a decentralized architecture, right? So when I say decentralized architecture, it's an approach where the application is composed of collection of smaller independent services and that can communicate with each other using a lightweight protocol, right? So that I mean that's what the microservices is, right? So when we're talking about the decentralized architecture, right? So what exactly that mean is it's an approach to building software system where the different components of the systems are distributed across multiple nodes or servers. In the decentralized architecture, there is no single point of failure. This is one important point to be noted. And each node is responsible for its own processing and data storage, right? Of course, this approach is often used in large scale systems that requires high scalability and performance and fault tolerance, right? If you have heard about the blockchain, so this is already being used there. And the main differences, if I talk about the main difference when we compare with this monolithic architecture and the microservices, right? The first is the size. So when we say size, monolithic architecture tend to be larger and more complex, while microservices architectures are smaller and more modular. And talking about the dependencies, when we compare these two, monolithic architecture have a lot of dependencies between components, making it harder, or I can say like changes to deploy and updates. Whereas microservice architectures are designed to be loosely coupled, with each services having its own independent set of dependencies. And also, when we have to compare the scalability between these two, uh, monolithic architecture can be harder to scale as all the components are tightly integrated, right? Whereas with microservices, individual services can be scaled independently, allowing for the greater flexibility and scalability, right? And talking when we talk about the deployment, right? So deployment, the traditional approach, the entire application to be deployed in a single unit, right? Whereas with the microservices, individual services can be deployed independently, and since we are deploying individually, it makes it easier to make any changes or updates without having the impact to the rest of the system. And when we compare the resilience between these two approaches, the traditional can be less resilient to failures, as a problem in one part of the system can cause the entire system to fail, right? While with the microservices, failures are contained to individual service, which makes it easier to isolate or I can say like fix the problems immediately, right? So overall, I can say like microservices architectures are more modular, scalable, and reliable than the traditional monolithic architecture. So that's the reason this is getting more popular approach for building large scale or complex applications. So some of the important concepts, I can say like key concepts in microservices that we can discuss is like single responsibility, right? So when I say about the single responsibility, this involves breaking down large monolithic application into a smaller, more focused service that each perform a single specific task, right? So obviously, when we are designing this microservices around a single responsibility, this becomes more maintainable, testable, and scalable, right? And if I have to really talk in context of mainframe modernization, right? This could be mean breaking down a legacy system into a smaller or more modular service that each handle a specific functions. It can be a authentication, it can be a data processing, or it can be a reporting, and so on, right? So, talking about the decoupling means this involves designing microservices in such a way that they are loosely coupled, meaning uh, each service can operate independently of other services, right? And this will lead in better scalability, easier maintenance, and yeah, obviously it's I can say like improved fault tolerance, right? So if I have to talk in terms of in context of mainframe modernization, right? So decoupling could involve begin designing services, microservices that can be like deployed independently of other services, so that any changes or updates on the service do not impact the rest of the system. And other important key concept here we have to know is like API first design. What is this? This involves designing microservices with a focus on their APIs, which defines how services communicate with each other. An API first design approach, I can say, like helps to ensure that microservices are interoperable and they can easily integrate with other services and applications, right? So these are the key concepts I can say, or I can say like these concepts of microservices, including single responsibility, decoupling, API first design, are very important to understand uh, when we are modernizing the legacy mainframe system using a microservices architecture, right? So this is about the key concepts, and let's look about the building microservices here. So microservices like when we have to build this microservices, right? So these are the important concepts that we need to understand. I can say like there are several tools and technologies that can be used to build microservices. So first thing is the containers. So what is this containers? Containers can be like, I mean, since I'm talking about the tools, right? So I'm not going in detail about the containers. So I can give just one overview of the tool names that we can use. So the containers can be such as like Docker and Kubernetes can be used to package and deploy these microservices in a portable, scalable way. And these containers enables developers to build, test, and deploy microservices in a very consistent and repeatable way, which can help to reduce errors and increase obviously agility. Okay, and talking about the API gateways, the tools such as like Kong, I haven't worked, but just know about these tools like Kong, APG can be used to manage, secure, and monitor the APIs that connect different microservices together. Since, as I told, like service should be able to talk to another service. So, API gateways can help to simplify the process of creating and managing APIs, and they can also provide features like authentication, rate limiting, and caching. Okay, and what is this service measures? Service measures such as linkered Listio. This can be used to manage the communication between the microservices by providing features like traffic routing, load balancing, and service discovery. And these service measures can help to simplify the process of managing and monitoring the interaction between microservices. And they can also provide features like circuit breaking and fault tolerance. And the next point to be discussed is the event-driven architecture. What is meant by event-driven architecture? Like what tools can be applied, or one is like AWS Event Bridge and other is like Apache Kafka. These can be used to enable microservices to communicate asynchronously based on the occurrences of events, and this can help to decouple microservices and enable them to operate independently, right? While I can say like overall, all these tools and technologies can be helpful in building these microservices. And especially when we're talking about the mainframe modernization, rights, by providing features like portability, scalability, security, and resilience. Okay. Uh, these are the things that an organization will definitely be considered. So whenever they want to modernize any of their systems, so to build a microservices, these are the four things I can say like very plays a very important roles like containers, API gateways, service measures, and obviously they have to follow this event-driven architecture. Okay. Now move on to the next one. So the challenges. Obviously, whenever you are trying to build any kind of a service or application or software product, definitely you will come across the challenges, right? The similarly, while building or while working with the microservices, the challenges that you may encounter is like one is service discovery, data consistency, testing, and monitoring, right? So what is this service discovery, right? So as uh, as we know, like in microservices architecture, there may be a large number of services. Since we are developing a smaller services, as we are breaking down the larger application to a smaller, breaking down into a smaller services, right? So obviously there will be a large number of created, and these need to be communicated with each other, right? This can make it difficult to keep track of which services are available and where they are located, right? So this one challenge that can be that you can come across, and how this can be overcome. They can use the service registries. uh, there are several service registries that may be available. Yeah, that I mean, no, it's not me. So that they are available in the or in the organization. Some of the organization they are using it. So one I am aware of it is like Eureka service. So which is being developed by the Netflix. So the Netflix is using this service. So they are using these microservices concepts. Yeah. Okay. And talking about the data consistency, so in a distributed systems like microservices architecture, maintaining a data consistency can be a challenge. Each microservices may have its own database, right? So, and changes made in one database may need to be processed to others, right? So, yeah, for every problem there is a solution, right? So there are tools like Apache Kafka and Apache Flink can help to address this challenge by providing a way of stream data between microservices. So these tools play a very key role. So when there is a challenge that is coming across the data consistency, right? So obviously for each services we don't know what kind of a data uh, base they are using it, and when there is a change in the database architecture and everything, so obviously, so definitely there would be a challenges. So but for, as I said, there is a solution for each problem. They are already tools available like Apache Kafka and Apache Flink that can address these challenge. Okay. And testing and monitoring, another challenge that we can come across is testing and monitoring in um, uh, as I can say, like in this microservice architecture, it can be challenging to test and monitor each individual services as well as the system and as a whole service, as well as a whole service, right? So, and it is difficult to monitor and test all these services, right? So, definitely they should go with some of the tools like Linkerd or Listio can address the challenges, right? And additionally, I can say like container orchestration tools like Kubernetes can help to automate and deploy their management services. So overall, building and managing microservices is the in context of mainframe modernization, I can say like it can be a very complex, but by using the right tools and right approach, the organization can address these challenges and build I can say like more agile, scalable, and efficient application, right? So these are the challenges that they can come across. So whenever they are using they're going with the microservices approach, right? So obviously, by implementing these best practices, I can say like, so as we had discussed, like using a service registry, implementing an event-driven architecture, or using a container orchestrating tools and implementing circuit breakers. So yeah, when I talk about the implement circuit breakers, I can say like these helps to manage the resilience of microservices. I can say like it is recommended to use circuit breakers such as like Netflix historic is one example I can say. Uh, this that is used to detect when a service is down or experiencing any issues. So since we have a lot of services now that is running, so earlier there may be one, maybe 100 services that may be running. So when you are implementing the microservices, the 100 turns into 1,000, right? So it will be difficult to monitor. So definitely they need to use this tools. So this Netflix Historics, I can say like use it it can be helpful to detect when a service is down or experiencing some issues, and they can switch to fallback or default behavior, right? So they have a lot of options to write, and this helps to prevent cascading failures and ensure the system remains reliable, right? I can say like overall by implementing all these practices can help address challenges in microservices and makes it much easier to manage and deploy services, and that can improve resilience and fault tolerance and ensures that services are loosely coupled and easy to maintain. Okay. Now let's talk about the very interesting one. So real world example of microservices. So I've listed few of the companies. So like American Express, Lufthansa, ING Bank, Netflix, Amazon, Uber, PayPal. So there may be several other companies where the microservices they which they have already they might be using it, right? So if I have to talk about, let me talk about the American Express, has been using these microservices to modernize its legacy mainframe systems by breaking down the monolithic application into a smaller, or I can say like the more focused services. So obviously, so what will be the outcome when they use these microservices? Improves their development speed and more agility, reduce their cost, and improves the scalability, right? And ING Bank is also using microservices to improve its banking system, including its mobile app and online banking platform. So here also the same approach. They have broken down its monolithic system into a smaller and more focused services. And the outcome was improve their user experience and the reduce cost and improving agility. And if I have to talk more about the Netflix is very popular. I know like 10 in 1 will definitely have a Netflix account and it can be shared, right? So Netflix perhaps one of the most well-known example I can say of any company that has successfully implemented these microservices. By breaking down its monolithic application into a smaller service, Netflix has been able to improve scalability and reduce downtime and introduce new features more quickly, right? So these are the common, I can say like the real world example that I can share as of now. Okay. Uh, yep. So that completes a simple overview on the microservices. So there are a lot of things. I mean, I can say like there may be a multiple concepts that can be discussed in these microservices, but I wanted to give some overview so that we can understand what's happening on these microservices in our day to day, right? So just wanted to conclude this by giving a summary. So microservices are an, I can say, like effective way to modernize legacy systems, improve scalability and agility, and reduce cost. However, they also come with some challenges, and that must be addressed, right? So by following best practices and adopting to the right tools and technologies, organizations can successfully build and manage microservices and realize their many benefits. And microservices have already shown can say like they have already shown a great potential in transforming the way we build and deploy softwares. As organizations are continuing to move towards more agile and flexible approaches to software development, microservices are likely to play a critical role in supporting these futures. And I can say, like in the future, we can expect to see even greater adoption of microservices as more and more organizations recognize the benefit of decoupled module architecture. uh, I can say like that are easier to develop, scale, and maintain. And last, I wanted to end with this. However, as with new technology or approach, they are also likely to be a new challenges. I can say like to hurdles to overcome, such as evolving standards and best practices. And definitely they need more sophisticated tools and platforms to support the distributed systems, right? So overall, the future of microservices looks bright, and it will be exciting to see how this architecture continues to evolve and shape the software development landscape in the upcoming years to come. Right. Okay. So this comes the conclusion. And thank you so much for watching this video again. I hope I was able to share some information about the microservices. And as always, if you haven't subscribed to my channel, so please do subscribe and give a thumbs up or comment. Okay. Thank you so much. Have a wonderful day.